voltage divider creates a voltage which is some fraction of its voltage source. It is a series circuit with output voltage is usually measured across the second resistor in a series circuit. We can write a general equation that describes the output of any two resistor voltage divider. So far, previously we have implemented Ohm's law, which states that V equals to I times R. So say you have an input voltage over here. I'm going to call it, say this is V in, okay? And then say you have a resistor. I'm going to say this is RT. And then the reason I'm labeling it as RT, I'm going to tell you later. And then the second resistor, say this is going to be just simply R. Okay, we know that because this is a series circuit, so it has some current which is going to be the constant and uniform throughout the whole circuit. The electrons are flowing from positive to the negative terminal. Um, Keep in mind we are considering the conventional current flow direction. Okay, so if I was going to measure the voltage across, say, this resistor over here, okay, so say I have terminals A and B, uh, and the voltage across it, say, is VAB. Okay, all right, so I need to find that voltage across this resistor R. So what I could do is say if I have, I can rearrange this equation such I equals to V over R, correct? In a series circuit, the total equivalent resistance is actually the sum of the resistance. So we have RT here plus R, so that is going to be the equivalent resistance. And the voltage source here is Vn. So I'm going to replace V with Vn here. And then R, which is the total resistance of the circuit, which is R equivalent, I can find out the current using this equation, right? Where I equals to Vn over uh, equivalent resistance, which is the total resistance of the series network. Also, from here, now that I know the current, I can just simply apply VR, which is going to be the voltage, or actually VAB, because that's how I name the terminals. VAB, we know the current going across this resistor is the same current I. We just uh, calculated I using this equation over here. Remember, I'm just doing it in expression form, so I'm not going to plug in the values. So VAB times, VAB equals the voltage across this resistor right here, and just simply apply Ohm's law. Current is going to be I times R, okay? All right, where for I, you basically plug in this equation that you see over here, and then R is basically this resistance over here, correct? Now, notice there is some kind of, um, derivation or transformation of the expression from here to, getting this over here. And then for that, we also had to calculate the total resistance, okay? How about if we can come up with a general equation that describes the output of the two resistor voltage divider? And that equation is, say, again, if you are trying to find out the voltage across VR here, R over here, all you need to do, you need to use this equation. So VAB, which is the output voltage, VAB equals to the total power supply, the input power supply, which is Vin in this case, Vin times the component or the branch or element across which you are trying to find a voltage. In this case, it's that resistor over here. So Vn times R divided by the total resistance of the network. And because it's a series resistance, and I told you already, we just sum up all the resistance. In this case, it's going to be RT plus R. Okay. this equation is going to give you the same answer that you would get from this equation over here. This equation over here. Okay. All right. So that was the basic behind it. Now I want to explain you, how voltage divider can benefit us do some quick circuit analysis. Okay. So say we can use voltage divider. Voltage divider. By the way, sometimes they are also referred to as potential divider. Okay. Okay. And then using them as sensor, okay, as sensor or transducer. So what is a transducer? It basically convert one form of energy to the electrical energy. Okay, and say you have LDR. Okay, LDR is a light dependent resistor, right? Light dependent resistor. Or another sensor could be, say you have a thermistor. Thermistor, and thermistor is a temperature dependent resistor. Okay. Okay. In other words, what I'm trying to say is, if you look at it in a graphical format, okay, on the x-axis you can have either temperature, okay, or the light intensity. Okay. Okay, so if you are using a thermistor, if the temperature increases on the y-axis, you're going to have resistance. The resistance is going to decrease as the temperature increases. Or if you are using a light-dependent resistor, when the light intensity decreases, the resistance also decreases. So there is a inverse relationship, right, between resistance and the temperature, or resistance and light intensity. So here is a scenario right here. What happens to V out as the temperature goes up? Okay, what is V out here is I'm going to label it as V out here. Okay, so that's the voltage across this resistor. Okay, as the temperature goes up. Now remember, we are using a thermistor. Okay, the property of thermistor is that when the temperature goes up, the resistance goes down. Okay, when the temperature goes down, the resistance of the thermistor goes up. Goes up. Okay, so now let's consider a scenario where temperature is going up. Okay, so temperature, like I mentioned over here, temperature goes up. Temperature, like maybe I can change the color here. So say temperature goes up. Okay, when temperature goes up, we know that resistance goes down. Okay, now notice, say this is your resistor right here, RT. This is the thermistor. Okay, I can say this is your thermistor. Okay, which has a resistance RT. When the temperature goes up, the resistance of the thermistor goes down. When the resistance of the thermistor goes down, which means if this number is smaller, then this number is also going to be smaller. So the equivalent resistance also goes down, correct? What happens to current? Okay, when the resistance is smaller, the current is going to be higher, right? There's an inverse relationship. Remember, I equals to V over R. Okay, if this number is smaller, then current is going to be high. And similarly, what would happen to V out? What would happen to V out over here? Okay, if the current is higher, then V out is also going to be higher, because remember, V equals to I times R. If I increases, voltage also increases. So in other words, when V out, what would happen to V out when temperature goes up? When temperature goes up, V out also goes up. Okay, now what we could do here, we could map the value of this voltage over here, okay, to a temperature. And when this V out exceeds some voltage, okay, so say maybe 8 volts or 7 volts, it can trigger a fire alarm or a smoke detector or something. So here you are basically using voltage divider to as a sensor in finding the values. And here's one example that we're going to do real quick over here. So say given R equals to 100 kilo ohm, so I can, R is 100 kilo ohm here, okay? We have to find RT, right? So we have to find RT. Vin is 12 volts here, and then V out is actually given, which is 8 volts, okay? Now simply I can just apply voltage divider here and calculate RT. What was the equation we got? V out equals to total input voltage, which is Vin times V out is basically the voltage across this R, so this will be times R divided by total resistance. In this case, it's going to be RT plus R. Now here, if I plug in the values, V out is given, which is 8 volts, correct? 8 volts. V in is also given, which is 12 volts, okay? Times resistance R is also given, which is 100K, 100 kilo ohm, divided by, you have RT plus R, which is again 100 kilo ohm. In this equation, all the parameters are known except for this much. This right here, you can rearrange the equation, do the math, and you'll get the thermistor resistance equals to 50 kilo ohm. Okay, remember that these um, thermistor, they come in different specification, different ratings. Uh, if you have these requirements right here, then you need to buy a thermistor which has a ratings of like 50 kilo ohms, which basically mean depending upon the temperature over here, it can vary the resistance between 0 to 50 kilo ohms. Okay, all right. Let's do another example right here. Um, Again, we have Vn over here. Okay, I have thermistor over here, and I'm gonna say RT, and then I have resistance over here. This time around, I'm going to measure the V out across the thermistor. Okay, okay. I'm gonna say this is my V out. Okay, and the scenario given is what happens to V out as the temperature goes down. Okay, here it was different. The temperature was going up. Here we are going to consider what happens to V out if the temperature goes down. Okay, so let's see what's going to happen if the temperature goes down. Okay, that means the resistance of the thermistor goes up. When the thermistor of the resistant goes up, that means the equivalent resistance is going to go up too. Okay. Equivalent resistance goes up too. What would happen to current? Current, you know, I equals to V over R. If this number is big, then current is going to be a smaller, right? And what would happen to V out then? V out is going to be smaller because V is a function of I times R. If I is smaller, that means the voltage is going to be, you know, on the lower side. Okay, so goes down, when temperature goes down, V out also goes down. Okay, so similarly, just like we were hoping that we can map the values of the V out to some temperature. Similarly, we can, map the value of this V out to the temperature, and if the V out goes below a certain level, it can actually turn the heat on. Okay, heat on when V out goes below a certain level. Okay, right? Um, so remember, the V out, going low would mean that temperature is going down. Okay, and temperature is going down would mean you'll start feeling cold, and therefore you need to turn the heat on. So this is how you can use voltage divider to find out the specific values for the resistors. Remember, this resistor value is going to be the fixed value right here for the R. Also over here, these are going to be the fixed resistor, fixed value. These values will change as a function of the temperature. We have one equation over here, and they are saying given R equals to 500 ohm, so say this is 500 ohm, V in is 10 volts right here. RT is given this time. RT is given 800, okay? And you need to find out V out. So we have to find out V out. Simply apply voltage divider. V out equals to 10 times 800 because the resistance across RT is 800 ohms divided by total resistance, which is going to be the sum of the two resistance, 800 plus 500, and if you do the math, you basically get 6.2 volts here. Okay, so um, remember, this 6.2 corresponds to some low temperature, and when this reading, when it goes below that, that basically means that temperature is also going down, like we saw over here. Okay, so that's the basics about voltage divider. It's one of the uh, technique that we could use to analyze circuit, measure the voltages and currents, and get the specific, uh, choose a thermistor in this case of specific ratings. Okay, so I hope you enjoyed this video. Thank you for watching. Bye.